Well, okay, good afternoon. My name is José Eugenio Ortiz. I'm a professor at the Madrid School of Mines and Energy from the UPM. We were going to be two, Pierre Sigma from Sigma, but due to different issues, he cannot be here. He's sorry about that. About this, well, I'm going to, after the presentation of Lorena, general presentation of the DigiEcoQuarry project, I'm going to present all the things that we are doing related to artificial intelligence and the digitalization of quarries and the future of the processes. First of all, a quick presentation of the different partners involved into this service, which is Sigma Cognition company. Well, I'm not from Sigma Cognition, so sorry about this, but just quick ideas. It was founded in 2008 by a Spanish guy. They have different locations, different buildings in Madrid, London, Miami, and San Francisco, but they have teams in more than 100 countries, and they work on artificial intelligence. These are the main goals of Sigma Cognition and Sigma around artificial intelligence. They apply this methodology to improve decisions, automate processes, increase revenues, and reduce expenses. And there is a second group in this for the development of the artificial intelligence services, which is the group of UPM AI. UPM is Polytechnical University of Madrid. There are people from 3 schools: the School of Mines and Energy, the School of Telecommunications, and also the School of Civil Engineering. But there are also professors from the Complutense University of Madrid and the Valladolid University, which are working together with Sigma. And although we are two partners, a company and universities, we are working very well together. We work as a single team. Well, Lorena has talked about the main objectives of the DigiEcoQuarry project. I'm not going to go in detail through them, but just a quick view. We have to improve worker health and safety and infrastructure. Also, we have to, another goal is to improve efficiency, selectivity, and profitability of the operation of quarries. We have to reduce environmental impact and promote social acceptance. All the partners that we are in the project are working hard to reach these goals. Lorena has talked also about the different methodologies applied, and we cover all the processes in a quarry, in the exploitation front, and also in the treatment plant, and also the commercialization of the product. Which are the main components in the digitalization platform? We have, first of all, the data lake, in which we put all the data. We have also the IoT platform, including sensors, to obtain data, automatic data, to put it in the data lake. We have the data warehouse. I will explain a little bit in detail the characteristics of the data warehouse. And the idea is to provide an artificial intelligence model, to use artificial intelligence model, also with platforms to reach the applications. In another area, you have the KTIs of the project involving, as I mentioned before, all the processes that takes place in a quarry, from the exploitation front to the treatment plant, to reach the goals of the project, which are in the center of this slide. We are working on 5 different types of quarries in different countries. Lorena has talked about the main objective of each of these quarries. One of them is centered in the public acceptance because it is inside a city. Another one is being used to improve drilling and blasting operations. Another one has been selected for the crushing optimization, a gravel pit. Another one has been selected for energy efficiency, and the last one for the efficiency of transport and storage. In all of them, we are talking about us, Sigma and UPM AI. In all of them, we are developing artificial intelligence services. This is a plot a simple plot about the origin or the different platforms and the architecture of the project for the artificial intelligence services. We have to take data on the field from sensors. The idea is that everything could be as much optimized as we can, and also from different sub platforms. And all this data has to be put into the data lake, and also information taken from the IoT platform. With all this data, which are on the cloud, we have to develop a data warehouse to manage all the information, to develop artificial intelligence models, and also BIM to provide the optimization of the different processes in the quarries. Here you have a summary of the data platform challenges. One main idea of the project is that it has to be affordable for all types of quarries. We have we have to connect all the activities, the machinery, the processes of any quarry, providing indicators and reports in real time. All the information provided by the artificial intelligence services from the data platform has to be manageable by workers with basic skills, which are the ones in general that are working in the quarries. It has to be adaptable, scalable, and replicable from quarry to quarry. In this regard, as we have mentioned before, we have selected different types of quarries, gravel pits, quarries sensu stricto, big quarries, small quarries from big companies, smaller companies. The idea is that all the things that we are developing has to be replicable and useful in any kind of quarry. And the data platform has to be able to work independently of any expert system based solely on the existing data and sensors. And it has to be able to integrate expert systems that complement all the data that we have from the quarry. Here is a general scheme. You have in the left part the source of the data from the IoT platform and the expert systems. We are or different partners are installing sensors and obtaining information from these sensors. And and also from quarry information systems. All these data has to be put into data lakes, one for each quarry. And then all this information goes into the data warehouse. As I mentioned, we use the data warehouse to, well, as a data repository, and also to manage all this huge information that we can obtain from the quarries. With this information, we can use it for data analysis, for data mining, for data reporting, and to develop the artificial intelligence services. It is important to say that an important process is the machine learning. Machines have to learn as far as we are producing data. And with all this information process, we have to provide different dashboards for the quarries in order that they can easily obtain the information and provide them information to take decisions in the quarry. So we are talking about the data. We are taking information from the quarries itself, from the data lake, passing through the data lake, but also from external sources. As I'm going to mention later, we are taking into account in some services meteorological data, which come from the different meteorological services of the different countries. So we put this into the data warehouse, and then it goes to the Power BI, to the different dashboards. And talking in detail now about the artificial intelligence services, I'm going to explain what we are doing in the quarries to improve efficiency, optimization, reduce environmental impact, and to increase the health and safety of the workers. We are developing 6 different services. One related to quality determination of the material. Another one, we are providing the granulometry of the material treated in the plant to check the final quality. Also, we are developing a service for the stockpile volume calculation. Also, another service related to the determination of mechanical failures using sound and vibrations of the different machinery. MetaQuarry, which is a searcher of the different documents, important documents of the quarries. And also a final service related to the consumption and production forecast. So regarding the first one, the quality determination, we are applying this service in a limestone quarry near Madrid. As you may know, limestones usually appear together with mud. The target material are limestones. The mud are the waste material. If we can reduce the amount of mud, would be great for the quarries. And in this case, we are determining the quality of the material. In this case, that means the percentage of limestones and mud using computer vision. But before installing cameras in the quarries, what we did was different laboratory analysis. One of them to determine the mineralogy of the limestones. Of course, they are made of calcite, calcium carbonate, but an important thing was to determine the mineralogy of the mud. In this case, what we observed is that this mud was made also of calcium carbonate. If the mud would have, if this mud, if this fine grain material had or were clay minerals, perhaps the cameras used for the identification of the material would be different as hyperspectral cameras. But in this case, we had to select normal cameras. And also for the detection of the material, we made some analysis with an spectrophotometer to detect the wavelengths in which the identification of each material would be better, as you can see in the bottom part of this slide. In these wavelengths, the identification or the separation, the differentiation of limestones and muds are better than at higher wavelengths. So with this information, we use this information to select the best cameras and the cheapest ones, but the better ones to detect the material. And in the right side of the slide, you can see a real picture of the material that is entering into the quarry, and how, and examples of annotation of examples of notation of this different type of material that is entering in the treatment plant. The cameras were, here there are examples of, and in the left part of the slide, example of a camera that was installed in the belt located at the primary of the quarry. And we also installed a camera just before entering into the crusher. With the information, with the identification of the material, in this case, the percentage of mud that is entering in the quarry using these both cameras, we are providing information to the quarry manager to know the percentage of waste material, and in order that he or she can take action in the treatment or for the treatment of this material. Another goal of this service is to detect big fragments entering into the crusher to generate an alarm in order to can take action before the crusher can be blocked or stopped by a big fragment, and also to take action in the front of the quarry during the blasting operations. Here, well, there is a video of this service. I hope that you can see it. Perhaps if no. Oh, there's no sound. I don't know if you can hear it. No. Perhaps here. No. I'm sorry because you are not hearing the. I'm going to pass it since the beginning. And no, aquí no. Oh. Here is the pilot site in which we are working on this service in Valdilecha near Madrid. Here is the entrance of the primary. You can see the location of the 2 cameras that we have installed before entering in the crusher, and also in the belt that is just below the crusher, in order that we can identify all the material entering into the quarry. Here is the architecture diagram of this service. And here, well, different images of the notation of the material. The identification of the material is based mainly on the color, based on this photometric analysis, and also based on the texture and shape of the material entering in the treatment plant. And here, an example of a dashboard that we can provide to the quarry manager in order that they can take action based on this service. Okay. The second artificial intelligence service that we are developing is related to the grain size determination, but after it has been treated. In this case, we are also using computer vision. We have installed a camera in a conveyor belt after crushing and entering in the mill, and after screening all the material. We are working with a 420 material. Here there is an example. In this case, we are only considering the size of the different fragments. You can see an example of notation of this material, and the idea here is to provide a granulometric curve, or an approximate granulometric curve, taking into account that we can have a certain segregation of the fine grain material that goes at the bottom of the belt, because with this camera we are also watching the top of the conveyor belt. But if we have information day by day, if we have this approximate granulometric curve of this treated material, if we can detect malfunction of the mills, if there is differences between a certain period of time, but also we are providing information of the coarser material. We are giving the percentage of the coarser or larger material that we have in the conveyor belt, to give information about the possible malfunction of the screens. So this is the main goal of this service. We have also another video. I'm sorry that you cannot hear the explanation, but I will give it to you. Let's see. No. Well. We are also working in Valdilecha pilot site near Madrid. Here you have the conveyor belt in which we install the camera to detect the quality of the material. You can see over there the stockpile of this type of material, the speed of the belt, which was a challenge. But we have solved all the issues related to the speed. Here are examples of the notation of the material. And yeah, the quarry components, the cameras, the architecture of the service, and also, well, an example of what we are providing to the quarries, as you can see here. Oops. An estimated granulometric curve, and with the different percentages of the different grain sizes. And in this case, an important thing is to provide a percentage of the coarser grains to detect any possible anomalies in the screens, or just by comparing the different granulometric curves if there is any anomaly at the mills. Yeah, another service is the stockpile volume determination. We are working in this case mainly in Italy, but also thanks to Valdilecha people and Big Cat people in Fenuyet for letting us taking videos and for this service. Okay, initially, well, we plan, or how can we calculate the volume of the stockpiles? We are comparing data taken from three different methodologies: from cameras, from drone flights, and from satellite, and we are taking satellite images. Initially, regarding the cameras, we plan to use fixed cameras for this service, but we needed 3 cameras to calculate the volume of a single pile. Imagine all the piles that we can have in a quarry, so that would mean a lot of fixed cameras and in a quarry, and not always in the optimal location. So, well, here we have an example of the reconstruction of the volumes of the piles using a drone flight. With only one flight, we can have the calculation of the volumes of the different piles. We are, as I mentioned, also taking satellite images from the European, from the ASI, European Satellite Agency, or European Space Agency. But finally, what we have developed instead of the fixed cameras is an app using in a mobile phone. What we have to do is just take a video around a pile, and in 15 minutes, we can have a reconstruction like the one that you are watching in this slide. And what we have measured, or by comparison with the other methodologies, is that we have an error less than 3% in the volume calculation. We are now working in the optimization of this app in order to reduce the time for the calculation of the volumes. And we are also working on the calculation of the volumes of not only one pile at the same time, but different piles. So we think that it is a very good service for the calculation of the volumes. It is very easy, and you can do it each time you want, not depending on the uh, considering a drone flight company or whatever. We can use this service not only to calculate the volume of the piles, but of other kind of material that you can imagine. So you have another video of this service. Here, well, there are examples. The app that we are developing, to the design of the app. As you can see, if we turn around a pile, we can have the calculation of the volume in a short time. We're applying this service in Pioltello and also in Fenollet, and also thanks to the people of Valdilecha near Madrid. Oops. Okay, another service is the MetaQuarry. It's in this case, it's the idea here is to use it as we can use Google, for example, to search information. In this case, not in in the quarry. For this purpose, we have put documents from the quarries. We have identified the words, the phrases that we have in the different documents, and we have developed this service for different languages, including Italian and French and also English. The idea is to spread this searcher for other languages using the technical language of the quarries. And with this service, you can easily find documents, including words that you want to consider. Here, there's another video about this service, which is developed entirely by Sigma. You can see the MetaQuarry features in this slide, and here you are going to see an example of this. You're going to see a demo of how can we manage the search of information using MetaQuarry. As you can see, we put different words or sentences, and the searcher gives you the documents, including the topic that we want to look for. ¿Los vídeos están en la web? No. Okay, another service, the fifth one, is related to the determination of mechanical failures using sound and vibration. In this case, we are working with the screens, conveyor belts, and crushers of the quarries. We have been using a recorder like this, but what we are installing in the quarries is a sensor like that. This is what we obtain from the machinery record of the sound and vibrations. And this works like if we were in our car, we usually hear different sounds, but if they change, it's because something is happening. In the quarries, the quarry manager and all the people, all the workers usually use the sound to detect possible anomalies in the machinery. With this service, as you can see in this slide, using the data from sound and vibrations, we have been able to identify different types of crushers, belts, screens also. So we have a cloud of points using these two variables. And when we have a point out of this cloud, is because we have an anomaly and we can provide an alarm or this kind of information to the quarry manager to check what's going on with the different machineries. Here we have another video of this service. We are applying this service in Mammendorf in Germany, but we are using data from other quarries, not only from Germany. Here you can see the record of sound and vibrations, the device that we have been using to obtain all this data. As I mentioned, we are working with crushers, conveyor belts, and screens. The plot that we have obtained using the information of the different machineries. And this is the sensor that we are going to install in the quarries to detect this kind of anomalies. And finally, the last artificial intelligence service that we are working on is related to the consumption and production forecast. In this case, we are working in the Portuguese quarry. We are taking into account data from the quarry itself, data from the production, daily production, also the energy consumption, electricity, fuel, also consumption of explosives, and also external data coming from the Portuguese Meteorological Service, including the predictions of temperature, rainfall, humidity, wind direction, which is important also to consider. Because with all this data all together, and also with some dust sensors that we have installed around the quarry, the idea is to predict or give information to the quarry manager about when it's better to produce the material, to reduce the water consumption if the humidity is going to be high, also to identify the dust coming from the quarry, and also the natural dust from the surroundings. So in this case, we are, as I mentioned, mixing or considering data from the quarry, also from meteorological from the meteorological service, and also from sensors that we have installed in the quarry to provide an optimization of the production, the optimization of the water consumption within a quarry. Here we have another video. Here you can see an example of the sensors that Sigma has developed. All the data here we are taking into account data consumption, production, example of the sensors, also water meter for the optimization of the water consumption. And here the pilot site in which we are working with this service in Alenquer from Simport. So, which are the lessons learned in this case? That quarries want solutions that are easy to use and maintain without the need of advanced skills. The data lake should use tools and metadata to handle the information available easily. The use of artificial intelligence is a great opportunity, but needs to be analyzed and adjusted to provide valuable insights into the business needs of the quarries. And also, the solution must be useful and replicable for the different types of quarries and companies. One of the main challenges that we have had is the data availability. In some cases, the data availability is scarce. In other cases, the data availability is huge, but it's not in the format that we have to or we need to work with. Another challenge is the data acquisition, the installing the sensors, or how can we obtain this data. Also, another challenge is the data processing of all this information. In some cases, a big, well, an important number of data. In some cases, the connectivity is another challenge. Quarries are in the field at, in some cases, long distances from Wi-Fi, good Wi-Fi connections, or so we have to, in some cases, we have to install antennas in order to send the data to the data lake or to the data warehouse, and also to consider quarries as system developers. And well, from my side, this is all. Thanks for your attendance, and if you want more information about these services, you can contact Pierres Plaza and also myself. You have the emails in this slide, and thanks all for joining this workshop.